Hi. Good morning. Good morning, everyone. Nikhil, Akhil, Shruti. Good morning. So, everyone, how are you? All of you had your tea, coffee. Yeah, is it audible or not? Yeah. All of you had your tea, coffee, hot water, juice, breakfast. Everything is over or not over? Everything is over. Harsh. Good morning. Right. So, yesterday we have done some questions on this, you can say, and we'll be continuing our questions on this again. Right. Up to which questions we have done, if you just remember, all of you? How many questions we have done, if you remember? Arey yaar, one sec, the PDF is not getting saved. One sec. Arey yaar, it is not saved. One sec. Yeah. Okay. So, anyone having any doubts in our questions up to yesterday's class, all of you? Anyone having any doubts anywhere in our class up to yesterday's class? Any doubts anywhere, all of you? Anyone, any doubts anywhere? Any doubts? Anyone having? All of you? Great. Hello, somebody tell me, any doubts are there or no doubts? If any doubts are there, we'll just discuss those doubts, but if no doubts are there, we'll proceed further. Someone? No? Okay then. So how many questions we have completed in yesterday's class? How many questions we have completed in yesterday's class? Anybody remember? How many questions we have done? 68 questions are done. Okay, so we'll be continuing from that 69th onwards, you can say now. Right. Okay. So this is lecture number, which one? Array, it is getting stuck in between. So lecture number 8. We are going for this on materials part only. Live test 8 on this materials part only, that a target SSC JE series, right? Mostly tomorrow we will be starting the second chapter, right? Tomorrow definitely we will be starting which one? Second chapter, you can say. Okay, tomorrow means yeah, tomorrow only. All of you, welcome to Unacademy. Let's crack it, right? Everyone get ready to crack. So this is my profile. You can follow me at which, and you can use this QR code for following my profile directly, right? Now what is it you can say here? This one, these are all the subjects I'll be taking in Unacademy now. So this is the lowest price ever for the last time, right? So last time means this lowest price conditions will not be repeated again, right? It's not, these lowest price conditions will not be repeated again, and price hike is also going to happen soon. So what is that referral code you have to use? That RP Civil is a code you have to use when you are subscribing to this 1 year or 2 year subscription. So 1 year 4,999, and for 2 years how much it will be? 8,999, right? So what is the code you have to use? RPC. Okay, up to April 27th only this offer is there. Okay, now, so what is that? This is a new batch starting, all of you. So Aarambh batch for this SSC JE English, right? So April 13th it was started, right? This is irrigation by KP sir was started, and myself advanced surveying has started, you can say, right? So these are all the features, you can say. So these are the features of this plus subscription. These are SSC JE toppers, right? So chapter 1 only. So 68 gets over, all of you. This is over. This is over. Okay. This is also over. Yeah, 66 over. 67 over. 68 also over, na? Yeah, 68 also over. Now 69th we are doing now. 69th will be going for now, you can say, right? Yes, now shall I start the poll? Shruti, Nikhil answered correctly. Pavan also answered correctly. Only you three are there? Yeah, yes, I'll see. I'll check it now. Because just before the class you have sent, I did not see that. Just after class is started, I have seen. So I thought of answering after the class. Okay. Right. What is that? A bar of this L meter length having its area of the cross section as A, and the subject, it is subject to a gradually applied tensile load of this W, that the strain energy stored in this is, right? Gradually applied load, right? What is the strain energy? You can say that W square L by this 2A in a gradually, which one? Gradually applied tensile load, right? That is your W square L by this 2AE, or W square L by this 2AE only we are having, right? Now shall we move to the next question? That's 70th question out of here. This is 70 question. Select the answer. Right, over. No. So what is this? You can say, sir is keeping polity quiz daily. At which time he is keeping? Yeah, Gaurav, good morning. At which time? Polity quiz. Why I do polity now? Amit Vijay sir is taking the general subjects now, so I will. Why I will touch then? I should not touch. This is not correct, na? I said no. When faculty is taking the subject means I should not interfere into his subject. Is not? That is not good. You ask Amit Vijay sir to keep. He'll keep na. I said no. Anyway, he is also supposed to take the special classes na. I'm keeping this class, these quizzes daily na. The SOM, technical, whatever the subjects I am taking, I'll keep, right? There is no doubt in that, right? So at that time, previously when nobody was there for general subject, I was keeping, but nobody was attended. But still I have kept for current affairs and polity some things. But now I should not interfere. That is not good, na? When a load is transferred through one surface to another surface in contact, then that stress is known as, right? What is the concept? When load is transferred from one surface to other surface, right? Suppose if you consider this is your what? Column, and what is this one? You can say this is your footing. So at the junction between this column and this footing, the load will be transferred, na? Yes or no? At this contact surface, right? What is that? We have to check it. Whenever there is a load transfer, right? We have to check for the bearing, na? Yes or no? Whenever there is a load transfer, right, we have to check for bearing definitely or not? Yes, we have to check for bearing definitely, right? Now, if you are considering this, what is that? You can say these are your plates. These are your plates, you can say. And what are these plates, right? This is your rivet or this bolt or whatever it is. Okay, this is your rivet or this bolt, whatever it is, you can say. So whenever the loads are applied, right, this is whenever the loads are applied, right, this will be applying that bearing pressure. This plate will be pressing this bolt like this, na? In this case, right, what happens, that bearing will come into picture, na? Is it no? It is not shear, Gaurav. It is which one? This bearing, right? Is there anything mentioned or nothing is mentioned regarding the bearing? Nothing is mentioned regarding the bearing, na? Is it no? Is it clear? Shall I go to the next question? 71st question. Yes, Shruti, tell me. Tell me, Shruti. Yeah, bearing means withstand, right? When the load is transferred from one element to the other element, the second element which is taking the load has to withstand it definitely, na? Has to take that load, na? If it is unable to bear the load, can you able to transfer the load properly? Suppose if your bolt is unable to bear that load, can it be able to transfer from this first plate to second plate, or it is impossible to transfer the load from one plate to other plate? It is impossible to transfer the load from one plate to other plate, na? When bearing capacity is not there. So that is why whenever there is a load transfer from one member to other member, that bearing stress comes into picture definitely, is not? Bearing stress comes into picture definitely, right? Is not? Select the value of for this. Already my full time is plus classes, 2 plus classes, 2 special classes, 4 hours plus 2 hours plus 2 hours, 4 hours plus these 2 hours, approximately 5 to 6 hours I am spending daily on this only. If I take quality, then it will I will not only midnight I have to take. Poisson's ratio for this steel with elastic limit ranges from, right? For this steel, what is the, you can say it is a 0.25 to this 0.3, na? Yeah, 0.25 to this 0.3 or 0.15 to this 0.2. Which one is correct, right? This option A is correct or option C is correct, right? Poisson's ratio for this steel, everyone. Poisson's ratio for steel is how much? Tell me. It is varying from which one? This is a 0.27 to this 0.3, na? Yes or no? 0.27 to this 0.3, you can say, right? If you just observe concrete, right? Generally used engineering material, civil engineering material. For concrete, how much it will be? 0.1 to this 0.2, na? And for cast iron, right? What is it? You can say 0.21 to this 0.26 we are having. And for this steel, if you just observe it, what is it? You can say 0.25 to which one? This is 0.3, right? Which one is nearby approximately matching? 0.25 to this 0.3 is only matching now. Listen, that 0.15 to 0.2 is for this concrete, okay, not for the steel. Is not rubber. If you just observe it, for this rubber, what is that? Yesterday we have done one question, if you remember, 0.44999999. So it is taken as which one? This is 0.5, you can say, okay, 0.5 you can say, right? Got it now, everyone? Right. These are the values we are having. Okay, is it clear, Gaurav, everyone? Now shall I move to the next question? 72 question. Baba. See, I am writing 8. What it is becoming, you see? I don't know what it is becoming. No. So what is that? If you just observe here, select the answer now for this 72 question. So the Pavan Nikila answered correctly. Sanjeet also answered correctly. Right. So what is it? You can say the ratio of this lateral strain, right? What is it? You can say the ratio of which strain? You can say lateral strain to the axial strain of a homogeneous material is called as, right? Ratio of this lateral strain to this homogeneous Langlands strain, right? What it is called as? It is your Poisson's ratio only, no? Yes, it is your Poisson's ratio only, absolutely, right? Yes, no? No. This is your 9th slide, you can say, right? Shall we move on to this next question? So 60 seconds time I am giving because little bit calculation is required for this. Yes, Gaurav answered correctly. You have answered for this only, Gaurav. 73rd question. Right. So the normal and the tangential components of a stress on an inclined plane through this theta to the direction of the force will be equal if theta is right. So when these are equal, if you just about this is your inclined plane, let us say just for an example, right? TP, good morning. So this is your inclined plane, let us say, right? What is this, right? This is your theta, sorry, this is your sigma you are getting, right? This is your sigma. At which angle it is present, that is your theta, right? Now what are the components? You can say one component is parallel, one component is perpendicular, right? What is this tangential component? You can say that is your sigma cos theta, na? This is your which one? This is sigma sin theta, right? Sigma cos theta, and this is your sigma sin theta, right? What is the tire pressure? That is different, this is different. Okay. So sigma cos theta will be equal to two components are equal, na? Isn't it? Two sigma cos theta will be equal to which one? This is sigma sin theta. So then what is that? Sin theta equal to cos theta, at which angle it will happen? It will happen only at this 45 degrees angle, na? Everyone. At this 45 degrees angle only it will happen or not among the given angles? Got it? No. So I'll move on to the next question. That's 74th question. Shall I go for? Okay. Oh, okay, okay. After this question, I'll wait. Don't worry. Okay, Stuti. After this question is over, I'll wait. Don't worry. Locus meaning it is the point. Suppose that that particular condition, any geometry satisfying that condition, right? Any geometry satisfying this condition. So our particular point will be on that geometry, right? That is what you can say. Okay, our particular point will be on that geometry. So the locus of which one? The locus of which one you can say? The locus of this end point of resultant of this normal and tangential components of a stress, right? Locus of which one? These end points of this resultant, right? On an inclined plane is, right? What is it you can say? The locus of which one? This resultant of what, right? Resultant of this normal as well as this shear stress. It comes to be which one? Tell me, anyone? That is your Mohr circle comes to be actually, okay? That is your Mohr circle, you can say. If you just here, if you are drawing this Mohr circle, right? What is it you can say? Let us say you are drawing this Mohr circle, right? At every point, right? What is it you can say? This point is a combination of which one? This is sigma and this is tau, na? Is that no? So resultant of which one? This is the point corresponding to which one? It is representing that a normal stress as well as this shear stress or not? It is representing that a normal stress as well as this shear stress, na? Is na? Locus means what? It is the point representing which one? It is a point satisfying our mentioned condition and resulting in some particular geometry. Okay, resulting in which one? This is some particular geometry. That is the meaning of locus. Okay, got it? So here circle it will be giving, right? Mohr circle is the locus of this end point of this resultant of this normal and this tangential components of a stress, right? Normal and tangential means what? Normal stress and shear stress, both resultant will be represented by this Mohr circle only, no? Every point, yeah, this P point is a locus point. That is a point satisfying which one? This is circular equation. Okay, this is also which one? This locus point is not. So this is also period where what is it you are having, that a normal stress will be there and a shear stress combination will be there, right? Like that, is not? At every point on the Mohr circle is representing which one? That normal stress as well as this tangential stress. Got it? Okay. Note this to the and tell me. In your +1, you have got this, na? So 11th class or +1, whatever it is. Sin theta equal to cos theta. Here cos theta equal to sin theta we are having, right? For which angle sin theta equal to cos theta? That means if you are taking this cos theta to this side, what is that you can say? Tan theta is equal to 1, na? Tan theta equal to 1 means for which angle of theta tan theta is equal to 1? 45 degrees only, na? 45 degrees only, it will happen like that, right? Isn't it? Right? Okay. Then this one, 74th. Shall we move to the next one, 75th? Select the answer. So 1 TP answered correctly. Principal planes are subjected to, right? What are these principal planes? You can actually, this is second chapter question. Okay, let it be. Principal planes are the planes on which what happens? Shear stress becomes 0 and normal stress will become this maximum. No? So only normal stress is present. Na? So which one? Only normal stresses are present. Shear stresses are not present or tangential stresses are not present. Then only those planes are called as your principal planes. Right? Got it? Is not? Shall we move to the next question? So the answer. 76th question. Gaurav, check it. Sanjeet TP answered correctly. What about the others? Right. Here, the strain energy due to the volumetric strain is directly proportional to the volume, directly proportional to the square of the external pressure. It is inversely proportional to the bulk modulus, and all the options are corrected. Which one you can say? That strain energy is nothing but your stress into what is it? We have to take it due to this volumetric strain. Na? Is that no? Stress into what is it? We have to take it. Volumetric strain we have to take it or not? Volumetric strain we have to take it if you just have it. Is not? So sigma into the delta V, right? Change in the volume. Now here actually what is it equal to? This is equal to, sorry, strain energy is equal to what is it originally? We'll check it. We'll check it which one is correct, right? Don't worry, we'll check it. We are checking now. So what is the strain energy actually? Stress into strain. What is the strain? Volumetric strain na? Into that volume. So what is that? We can write it if you just observe that is stress into what is the volumetric strain? Delta V by this V into that V na? Is that no? Delta V by this V into that V na? So this V cancels, right? That is why I have written that sigma into delta V, right? Now understood why I have written that sigma into delta V? Now here strain energy due to the volumetric strain. What is it you can say? That strain energy is directly proportional to this V or not? Volume. It is directly proportional to this volume, is not? And it is directly proportional to the square of this external pressure. Is it directly proportional to the square of this external pressure, or it is U is also directly proportional to this sigma only? Square of the pressure, pressure power 1 only, pressure or stress power 1 only. It is inversely proportional to the bulk modulus. No, it is not inversely proportional to the bulk modulus. It is directly proportional to the bulk modulus only, no? So no. No. Here, tell me, what is that? Which one is appropriately correctly present? So this is which one? Stress into volumetric strain into volume. So strain energy is directly proportional to volume is the only nearby correct answer present or not? That is the only nearby correct answer present, you can say. Is not clear? Shall I go to the next? '77th question, shall I? Why it is rotating in the YouTube, I don't know. Sometimes suddenly it is rotating the screen. Yeah, TP, Sanjit, Shruti, Pavan, Nikhila answered correctly. Yeah, this is the question everybody answered, na? You should have to answer correctly. If not answering correctly, na, I will be bringing stick. Because this is chota bacha question, na? The ratio of this longitudinal stress to this lateral strain, right? What is that? Longitudinal strain to this longitudinal strain. Ratio of this longitudinal stress to the strain. So longitudinal stress to the strain rate, what is it? You can say Young's modulus, na? Yes, Gaurav, correct, right? It is a modulus of elasticity or not? Young's modulus, E value. What is this one? Shear modulus, G or N or this is C equal to, what is it? You can say that is your tau by this phi, na? Bulk modulus, what is that? K equal to, what is it? You can say K is nothing but your sigma by this volumetric strain. This tangent modulus of elasticity, that is ET we are representing, na? ET. Is not? It is equal to simply the slope of this curve or not? It's the slope of this stress strain curve at any location wherever you want. Right? Shall we start the ball? Select the answer. '78th question. Sanjit, Pavan, TP, Shruti, Nikhila answered correctly. Right. So what is that? The property of a material by which it can be beaten or rolled into the plates, right? Thin plates or these sheets, right? What is that you can say? That is called as your malleability, na? That is called as your malleability or not? That is called as your, which one? This is malleability, you can say, right? And it can be rolled into the thin wires. When it is rolled into this thin wires, right? What it is called as? It is called as your ductility, na? Into thin wires, if you are doing that, that is called as your ductility, you can say physiotherapy. Is it? So which one is the answer? None of this is the correct answer, na everyone? None of this is the correct answer, you can say it. 79th question, shall I go for? Select the answer. And press correct answer. Shruti, Sanjeet, Pavan, TP, Nikhil answered correctly. Everybody answered. Yes, very good, very good, boys and girls. Right. So what is it? What is the limit of this Poisson's ratio? Or what is the maximum limit of this Poisson's ratio? That is your 0.5, na? That mu. So is there any value given? No value is given. Is not? This is 80th question. Question number 80. Already this question is repeated now, if you just remember all of you. This question is repeated already or not? %, correct answer. Very good. Yeah, poll is still running. 1 second. It's over. Among the following, right, which is least elastic, right? Which one is least elastic, right? Rubber is the least elastic, no? Yes or no? Because even for small load itself, it will be losing its elasticity. Permanent deformations will come into picture, right? Today will be the last question we'll be doing. So tomorrow, this first chapter gets finished. If possible, we may start the second chapter also, right? Okay. Now, so up to this 2018 done na? So 2019, 20, 21, 22, 23. 5 more years questions we have to do now still. Pavan Sanjeet answered correctly. Right. Two bars of different materials are of the same size and are subjected to same tensile force, right? Same tensile force means same size and same tensile force means, right, that A1 equal to that A2, and what is it you can say? P1 is equal to that P2 na? A1 and P1 both are same na? Cross section area, and these loads are same. If the bars have the unit elongation in the ratios of 4:7, right? So what is it you can say? That is delta 1 by this delta 2 is equal to that 4/7 only na everyone? Elongation ratios delta 1 by this delta 2 is 4/7, right? Then the ratio of this modulus of elasticity of these two materials is, right? So here how can you get that if we just observe delta 1 is equal to which one? PL divided by this E1, isn't it? Because P is the same, length is the same, A is the same, sizes are same means L1 is also equal to L2 na? And what is that delta 2? You can say delta 2 is nothing but your same P only, same length only, divided by which one? This same area only, but E is different, right? Now tell me what is that delta 1 by this delta 2 is what? Delta 1 by this delta 2 comes to be PLA cancels, E2 by this E1 comes now. Then what is that E2 by this E1 comes, right? Then what is that E1 by this E2 is how much? Tell me. This implies that what is that E1 by this E2? E1 by this E2 comes to be delta 2 by this delta 1, right? What is the delta 2 by this delta 1, right? That is your 7/4 now, exactly. That is your 7/4, right? But is there any option with the 7/4 or no option with the 7/4, right? No option is there with the 7/4 now. None is the correct answer. Got it now? Everyone is clear? Everyone is clear, all of you? See, what is the delta? PL by AE is the delta for this axially loaded member na? That point is clear, Shruti? Delta equal to PL by AE is for the axial load na? So no, delta equal to PL by AE is for the axial load. Is na? So delta equal to PL by AE. So here load is constant, length is constant, area is constant, because sizes are same mentioned na? All sizes, cross section sizes and length sizes all must be taken same. Therefore delta is inversely proportional to E1 na? Delta is inversely proportional to this E or not? So delta 1 by delta 2 is equal to E2 by E1. E1 by E2 equal to delta 2 by delta 1. So means that 4 by 7 will become ulta, 7 by 4 it will become, right? Got it now? Gaurav? Yeah, repeated second time also. Gaurav, is it clear now? Delta equal to PL by IE. Load is ulta means reverse. Load is constant. Sizes are same, na? Sizes are same means what is the L is the same. Array, here it is like that only, it is varying, na? How it is varying, tell me. Delta is equal to PL by which one? This AE. Okay, and load is constant, so you need not consider. Sizes are same for both. L is constant, A is constant. Therefore, that delta is inversely proportional to that E, na? This implies E is inversely proportional to this delta, na? Yes or no? Then you are asked to identify the ratio of this Young's modulus. What is that ratio of this Young's modulus? You can say E1 by this E2. What is that E1 by this E2? E1 by this E2 is nothing but your delta 2 by this delta 1 only, na? We know this delta 1 by delta 2 as 4 by 7. So delta 2 by delta 1, how much it comes to be? 7 by 4 it comes to be, right? Now understood why it is taken ulta? Got it? Because E1 by E2 only you are asked. Yes, na? Got it? So I'll be closing the session. Thank you all of you. Tomorrow, first chapter, all questions will get over mostly. Okay? Tomorrow, first chapter questions will get over. Right? Thank you all of you. Have a good day. Bring all your friends and you attend regularly up to your SSC examination. Right? Don't miss this. Thank you.